Hey, this is Unphazed, and I have decided to go through a little bit of simple circuitry and teach you how to build an elevator today. Automated elevator. See, it looks very confusing, and it was kind of to build, but the principle goes something along the lines of this. If I can get in there, obviously if you were going to build this and put it in something, you'd want to streamline it a bit. To be honest, all you'd really need to get rid of is this arch, which is the arch I've put in to put the switch upstairs, so really that's nothing too arduous. Now if I stand on here, flick the switch, lift it up to the next level, so I've gone up 4 floors. And then if I stand back on here, now this one is not quite so streamlined because I made some slight adjustments just before I start the video. So it does take, the last one takes a little bit longer. Is there a reason for this? Good question. Yeah, there is. The reason for it is there is in one of these circuits I'll show you later. Over here, circuit 3. It's a bit slow. The repeat's a bit slow, and but we can sort it out. So what I'm going to do is show you the general principle of how that's done, and the way that is done is. Hang on, excuse me 1 second. I just need to go back and turn off the negative circuit. Go away. Thank you. Righty-ho. So this is your origin point. You've got 4 pistons. They're sticky pistons, obviously. 4 sticky pistons. And then 2m minus 1. So there's a little bit of mass in this, but not a huge amount because I'm not particularly good at mass. That's fine. Very good at randomly pressing space bar too many times though. So basically, if for 4 it's 7, for 5 it's 9. Because what you do is you go around in a spiral is the best formation because it means that they won't crosstalk. One of the biggest difficulties in building anything like this is crosstalk. This is all going to look very complicated as I spin around. You can see everything else that's going on. You can see the Colosseum I built as well. But the reality of it is that I'm going to break it down really slowly. So to elevate these 4, they have to be in order. So the first one has to go up, and then the second one has to go up, and then the third one has to go up, and then the fourth one has to go up. Obviously the bases are going to move, so the switch you need to put on needs to be where the base will be, not where the base is now. So it's, oh god, sorry, apologies, it's odd numbers. To go up, 1, 2, 3, 4, 5, and then the top one, 7, because there's 6 there and there's 7 there. So now that is fully elevated. Now, if we reverse that, 7, 5, 3, 1, and we're left with this. So, how do we get back from this? Well, what we need to do is to go for 4 to bring that one. We need to bring the top one down first, so 4 twice, on and off, and then 2 on and off, and then 3. Oh god, sorry, 3 on and off. And then that brings the stack back down. So those series of movements is what all of that does. Turning it on, not too difficult. All you need is a delayed circuit. Now a delayed circuit looks something like this. So our 2 friends are the redstone repeater and the redstone comparator, not the sign, the redstone comparator. Get to the redstone comparator in a minute. So the redstone repeater, in its most basic form, re-intensifies any signal. So if it gets any signal in the back of it, here, at the back of the triangle, it puts out full signal at the front, and the full signal can go 15 blocks. It also adds a 0.1 second delay, which is the thing I use it for most often. Now you can change the delay by right-clicking this little beast here, and that can take it anything up to 0.4. So that's 0.4 at the back, that's 0.1 at the front. So one of these turn on full, and one of them is half second. Okay. So with the switch here, we have a straight line running along. Now this is where we come. I put this in just to make sure I put one in at the same level all the way along here to make sure that the intensity was fine, because I didn't know exactly how long I was going to make the arms originally. The other thing to say about these, and this doesn't matter for now, but will it come in to importance later, as these act like diodes. If you ever do physics, you'll know about these. Basically, the current can only go from the back of the triangle to the front of the triangle, from the bottom to the top of the triangle. So if I put a torch on here, it will light that one and that one, but it won't go through. And now we come to one of the really important points of all this circuitry, is that if you want a delay, if you want something to one thing to happen after another, it needs to be 0.2 seconds afterwards to allow for the actual function to happen. So let's say that this takes 0.1, the piston takes 0.1 seconds to go up. That takes up one of these, so you need another one. Okay. You can just have one of these and click it back one. I've done it with, and most of these circuits, apart from when I was fiddling around on the big circuit at the back there, most of these circuits I've put an individual repeater down for another 0.1 of a second, and that is because it's graphically a lot easier if you're doing a massive circuit. If you can see, unless you know exactly what you're going to do, if you can see exactly where all your delays are, it's easier. So we've got a set 0.1, 0.1, 0.1, obviously the 0.2, but you've got the piston delay as well. So if all goes to plan, when I turn this on, it should go this one, then this one, then this one, then this one. I'm going to stand a bit over here, make sure the visibility is okay, and turn it on, and there you go. And when you turn it off, it will come from this direction. Down, down, down. Obviously, it jumped a bit because I was slightly out of range of visibility. Now, what we need, ideally, is for these pistons to turn themselves off. So I've put a comparator in this circuit. So this is exactly the same. This shape is exactly the same as that one over there. And I put a comparator in. Now this is a comparator, and you can see it's got 3 on it instead of 2. The function I use the comparator for mainly is that if I put a really strong current in from the side, it stops anything running through the comparator. Best way to put a really strong current in from the side is to put a repeater right next to it, because then it has full impulse. And as long as the one behind it is more than 2 away, then that will override and it will no longer allow current through. I know it's redstone, whatever, but I'm just going to refer to it as current, okay? So we've got the exact same thing again. It's going to go up, it's going to go up, it's going to go up, it's going to go up. Graphically, again, I've done it exactly the same. So these are all 0.1. So it's 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, and then the one that's on all of these, so another 0.1. So it's 1, 2, 3, 4, 5, 6, 7. So what I've done is then add in a loop circuit here, another loop, which has a delay that is longer than all of those will take to fire. So longer than 0.7, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, we've got the 0.1 for the piston, so I've added an extra 2 on, okay? 0.1 for the function at the end of the circuit, so there's 2 more, okay? And again, it's graphic, so all of them are on 0.1, as opposed to having, if I wanted 0.9, I can have 2 of them at max and then another one of them, which is useful for saving space. So what this is going to do is they're all going to fire, and then this is going to come around, all the way around the circuit, and come into this side of the comparator here. Now, because the signal from the side will be stronger, as you can see there's more of a 2-block gap, it's going to cut this off, okay? Or that's exactly what should happen. So what should happen is that these should all fire, all the pistons should go up, and then they should all come down again. See? That's what happened. And I can turn it off. And when I turn it off, it turns both of the circuits off, but that means there's no current at all to flow through, so they don't go back up. So that's how to do the sequence. So if you imagine instead of having these go out sideways, if we flip this 90 degrees, and obviously all the pistons faced upwards instead, stack them, that is how you turn this on. You got 1, 2, 3, 4 to turn on, 1, 2, 3, 4. And that essentially is a circuit that's on the right hand side as we look at it, over there. Okay? Righty-ho. Now what we need is the ability to go up and down. So, you know when I did, tell you what, we'll open up again and we'll go through it again one more time. 1, 3, 5, 7. Now, 6 actually holds no function at all, but it's, prettier. So, and then we turn them off again. Come on, go away. Come on. I'm not close enough. No. Thank you. Right. So what we needed, didn't we? We need 4 to go up and down, didn't we? It needs to go up to grab the piston, down to bring it back. To do that, we need the same thing as we had over there. Now I'm going to show you exactly how you build that. So what you start off is you need your circuit here, which is going to make this fire, okay? And if you put some delays in it, then you can change the speed it fires at. So hang on, just get off, stand over here. So if we've got a 0.3 delay in, I haven't got a switch on here actually, but I can. If you put a switch on here, turn it on, and then turn it off, a pulse will run around. As long as you do it quick enough, a pulse will run around, and it will keep going around and around and around. And the speed at which it goes around is determined by how many repeaters there are in the circuit. Excuse me. So we can see properly how many repeaters there are in the circuit. Okay. So then if we move along, we've got exactly the same circuit as you can see there, and then we've added this structure behind it. Now this is the structure you need. We're going to have the impulse, because you remember I said if you turn it on and then off quick enough, so that's an impulse, isn't it? It's like having a button. There's a reason we don't have a button. So this is where the impulse is going to be generated in this circuit here, and this is going to this arm here is going to decide how many times it fires, okay? So this is your impulse circuit. Again, we've got a delay here running through, so I switch it on, it runs through to there, and then there's a extra 2 delay on this side. As you can see, we've got a repeater next to a comparator, so that's going to cut the comparator and no more will be allowed through. Okie doke. So if I turn it on, it goes up and down. Because you can see, this has been blocked here, so it no longer, the reason this is flashing is because the current's coming back round, and it's not going through here. As you can see, it's not flashing on this side, that's just still getting supply from the switch. And I put enough current through, or enough time through, that it doesn't fill the whole circuit. It has gaps in it, which means it pulses around like that, okay? And that will go up and down, up and down, up and down, up and down. But that's not what we want. We want it to stop, don't we? And the only way to stop this is to cut the circuit. So how do we cut the circuit? Well, we cut the circuit with exactly the same principle we had over there, which is to put in this arm, right? So this arm connects to this comparator here. We've got the repeater, and again, I've done it graphically, that's why there's so many of them. We've got the comparator here and the repeater to come in. The number of circuits, or the number that this circular route here does, therefore the number of times the piston goes up and down, is determined by the ratio between this arm here and this circuit, okay? So there are 0.3 seconds to go all the way around there. So we've got 1, 2, 3, 4, 5, 6, 7. So we've got 1 for the function, whatever the function might be. The function is sometimes just turning something on, current flowing, you know. Always add 0.1 or it will not work. So it's double. So this is double the time. So basically, that's going to get to go around twice before the comparator stops it, okay? Before the current through the side of the comparator here is stronger than the current going around the circuit. Now, if I've got this right, we should get 2 piston pumps. There you go, 2 piston pumps. And then you can turn it off again, and they all turn off. Because this one's blocked, and this one's blocked, so there's no more current going into the piston circuit. So when you turn it on, 1, 2. Now, if I wanted to make that 1, as I do over there, all I have to do is have 1, 2, 3, 4. Let's take these out. And it should give me 1. There you go. 1. And that's what I want over there, isn't it? Okay? So, this is what I've done. If I fly over to my elevator, I have, and it's a bit difficult to get in and look exactly, and that I can only apologise for. Now, just one quick point I should point, or one thing I should point out, is that you have to use something that falls. So gravel, sand is the best. Now, the reason for this is if you use solid blocks, the one on top of the sticky piston will come down when this piston retracts. But when this piston is moved, it will stay where it is. And if you've got anything else on top of it, then they'll just stay in midair. Okay? So you need gravity to have an effect. as you can appreciate, if you drop sand from a great height, which I will try and do here. Let me see there. Nope, that's not high enough. Sorry, what I can do is this. I didn't think to do this, sorry. Kadake, drop that. Oh, it's landing on sand. That's just perfect, isn't it? Never mind then. The principle is, and I'll just do it here, it's if it lands on top of anything below, you see. So, there we go. Sorry about that, just idiocy. There's something on that block, so the sand basically despawns. So it doesn't despawn, it's still there, you can pick it up, but it goes out the column. Sorry about that absolutely atrocious demonstration. I hadn't tried that before, I just knew that it happened. I hadn't actually tried to see the origin of it, and I'm imagining, therefore, the origin is the redstone. But it also happens if it falls too quickly, okay? So you need to have a reasonably slow circuit. Now, what we needed was 1, 3, 5, and 7, didn't we? Now, 1's down there, as you can see, base level. 3 is here. 5 is here, and 7 is up here. Okie doke? So when they fire, it pushes it up, and that's what we did with the on switch in here. And there is your well elevated, and you can see all those circuits are exactly what I said. And as you can see, we've just got the delays here, delays, and that is your extended piston circuit. One, extended, 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 extended. So, then we need to turn it off. So what I've done, again, is I've done exactly what I explained to you over there about cutting circuits over here. Cut the circuit. And what I've done, instead of having it on delay, I've had it on a switch, because obviously you're going to want to switch at the top of the elevator to go down. So I've got a repeater going into a comparator. Now I've put the comparator on 7, 5, 3, and 1, and then I've got a repeater going to the side of them. So when I switch on that current, it runs in, and it's stronger impulse from the side, so it switches them off. So all 4, 7, 5, 3, and 1 switch off. And as you know, when you switch 7, 5, 3, and 1 off, you get that stack, don't you, where there's 2 based at the bottom. Hang on, I will show you exactly what you get. I could cheat by respawning them, but instead I'll show you exactly what you get because it makes sense to do it. So, 1, 3, 5, 7, 7, 5, 3, and 1. So there you can see we have the double stack at the bottom and then the single stacks. Now if you have a taller column than this, it's double stack, single, 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 single till the end of time. That needs to be taken into account. You need to bear that in mind. So when I cut these off, you get that shape, which means we then need to fire 4 twice. Remember, it was 4 twice, then 2 twice, then 3 twice. Okay, and this, I say fire it twice, I mean turn it on and off. Right? So this was the circuit required to turn it on and off. Remember? On, off. And that's all we needed to do. It's really quite simple when you think about it. So these are what these circuits are here. And the reason they're so long is just because moving around, obviously I can have a single gap between circuits vertically, but obviously I need to get between them because comparators and repeaters need to be laid directionally. So if I'm looking this way, the repeater will face that way. So I need to be looking that way to lay it that way. And that is the reason. Okay? So my lift is at the top. I have the current going down here. And it goes into a central point, actually, which is here. This is the central point. All the current is coming from here. And then it's going out, and it's going up to 7 to cancel 7. It's going to 5 to cancel 5. It's going to 3 to cancel 3. And it's going to 1 to cancel 1. The repeat circuits, so the 4, 2, and 3, which need to go up and down, are all coming out this line here, if you follow my cursor. Coming out this line here. And then we've got 4, 2, and 3 going out there. Now, all I had to do was make sure that the delay from turning off goes down from the top. So I need to make sure the delay was shortest for shutting off 7, and then slightly longer for shutting off 5, slightly longer for shutting off 3, and then even longer for shutting off 1. And then I worked out the total time it takes to shut off 1, and then that was the time that I needed before we could start with 4, okay? So I came out, and this was it here. So I came out, and then we go down, and it shuts off 4. On, off, 4. And then I add in that delay and put in more, put in another 2 blocks. Again, remember the 2 block difference. To do 2 up and down, and then I had even that delay and another 2 blocks to set up 3. And as you can see, it's exactly that design I showed you over there when we were building it. It's exactly the same design. I've got the impulse circuit, which is this rectangle here. I've got the timer, essentially timer here, and I've got the repeat circuit. Now obviously, slightly different because the piston isn't here. But naturally, to turn this circuit off, and this 3 is the only, in this one, 3 is the only case. And if you did it higher, it'd be 5 and 7 kind of thing. 3 is a special case. So on this one here, like this, what we need to do, because our initial thing in the 753 turning off was to bring an, if I can get into the side of it, sorry, it is quite difficult to get into these, was to bring into the side of the comparator here, the repeater into the side of the comparator, to shut, when I turn it off, to shut the comparator off, okay? To get it to fire again then, I need to release this effect from the repeater. The way to do that is by blocking my blocking circuit, which is why instead of having a piston here, I've got another repeater going to the side of the comparator, which turns this off, turns this whole circuit off, which means the original circuit can fire again, it goes up, this then, the pulse goes away, this relaxes, this goes back down, turns it off again. And the way that works is, if I do this, or get close enough, do that, it should, see that pulse there, see it turned off, you see that? It turned off on the screen just there. And that turning off was that one. So when I go in here, which I don't, yes I can do, and I look down, it's gone, see? It's gone down 4. And that is the beauty of it. So that is how you build an elevator. Now as I said, all you would need to make this easily accessible, I mean yeah, it's quite large, you can make this smaller, again don't forget, all you need to do to make this smaller is work out, or just quick pen and paper, you know, it might sound like an extensive thing, but it's pretty cool to have one of these in your house on Minecraft. All you need to do is, if you take all of them as 0.1, and you can see some of them here actually aren't, and that's because I was messing around with the circuit just to see what I could do with it. Take all of them as 0.1, and then work out the exact delays to each endpoint. Now the endpoint's the piston or the blocking circuit, so work out the exact delays, and then if it's say 1 second, then you just need two repeaters turned on full, and 1 repeater turned on to 2, and that's 1 second. So you can get rid of lots of the repeaters. And by doing that, you can make the circuit a lot smaller, okay? But it's not graphic, and therefore you guys can't see it if I'd done that. You wouldn't be able to appreciate exactly where the ratios are and things like that, okay? So all you'd have to do to be able to put this in a house would be to take rid of this, and that would be easy. All you have to do is go around the back with it, because this is just the switch. So you go around the back with it, and if you come down to here, you might want to, if you just brought this across one, step up, and you can walk out through here. And you'd never see it. And that's the thing, you'd never see it. You'd have the rest of your house where I'm standing, and over here somewhere where that Enderman is, you know, as big as you want, or as small as you want, but you'd have a lift. And that would be awesome, wouldn't it? So guys, that is how you build a lift. It's a lot of circuitry, but as you've seen with this zombie over here, and the way I've shown you to build it, really it's just combining very simple things. All I've got actually in that whole thing is one of these circuits here and 3 of these, 2 of them with a piston on the end and 1 of them with a comparator on the end. And that is how you build a normal, therefore a reasonable distance so you can get a roof between the two, a normal elevator. So that's how you do it. If anyone needs more further instruction, if you're not sure about anything, please, let me know in the comments. Give me some feedback. I'm very, very happy to break this down even more basic. I will actually build the whole thing on one plane if that's what you need me to do. On one, episode. I'm very happy to do that. These are going into my Colosseum because if you think about it, hang on, what I need to do, I've got slight adjustments to make, which I will show you. I didn't want to put them in here because it's going to make it really complicated if I did. So what you have to do is you have to turn off the bottom one and then turn off the top. And that's because of circuit. So if you imagine, actually, and I can show you now, right? If you imagine that this, instead of being dirt, is made out, instead of being nether brick, sorry, it's made out of sand. Then when I'm in here and turn this on, comme ça, like that, like this, it brings me up into the arena. And that was the point of it. That was the point of it, was to bring me up into the arena. Now I'll go back down. And actually, I also, you can slow that last delay, and I'll show you exactly where that delay is. So that last delay, remember, it was how quickly it took the pulse to get around, wasn't it, right? And how long it takes for the pulse to be generated. So all I have to do for that pulse to be generated quicker is to speed this circuit up. You can see I've got 4 there, a 2, 3 there, 3 there, a 3 there. Speed that up, that pulse will happen a lot quicker, and that last bit will come down faster, so you won't have that delay. The reason there is that delay is, as I say, I was slightly messing around with the circuit. So that will bring you up onto the field of battle, is the whole idea, because you can leave it up, obviously. You can leave it up, you can walk away, you can come back, you can go down again. The only thing about this is that you have to go up and down, okay? So that's something to bear in mind. What you could do would be have 2 of these next to each other. And there you can go up and down, and that would be feasible, because what you could actually do is put all the circuitry on one side and then all the circuitry on the other side for the 2 of them, okay? So that is my elevator, guys. Thank you very, very much for watching. As I say, I'm happy to build this in one go. It looks complicated, it really isn't. If you got any questions, please send them through. It's a really simple bit of circuitry. But it's a lovely bit of circuitry, isn't it? Because you can build an elevator. You can have an elevator in your house. Then who needs stairs? It's a flick and you're up, 4 blocks or 5 blocks or however many you want, okay? So, guys, thank you very much for watching. Sorry, I just hit the mouse there. I'm going to sign out now, and I really, really hope you enjoyed it. I really hope you learnt something from it. Please like, comment, subscribe would be great. But it doesn't matter, but a comment will be awesome if you've got any questions or anything you want to point out to me that you think I've missed, anything like that. That'd be awesome. So thank you very much for watching, guys, and I'll see you soon.